Hello students, in this video we are going to discuss 3.4, 3.5 and 3.6 from current electricity. These question numbers are as per new updated textbook. A negligibly small current is passed through a wire of length 15 meter and uniform cross section 6.0 into 10 power minus 7 meter square, and its resistance is measured to be 5.0 ohm. What is the resistivity of the material at the temperature of the experiment? Here the given data, what we have, the length of the wire L is equal to 15 meter and area of the cross section 6.0 into 10 power minus 7 meter square, resistance 5.0 ohm. We need to find out resistivity, and the temperature is constant there. So we have the formula R is equal to rho L by A. From this, rho is equal to RA by L. All the values are given. R is 5.0, A 6.0 into 10 power minus 7 divided by length 15 meter. All are taken in terms of SI system. So after simplification, we will get 2.0 into 10 power minus 7. The SI unit of resistivity is ohm meter. So this is the resistivity of the material or the wire. Coming to 3.5. A silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius and a resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of resistivity of the silver. The given values, resistance R1 is equal to 2.1 ohm at temperature T1 is 27.5 degrees Celsius. And the resistance R2 is equal to 2.7 ohm at T2 is 100 degrees Celsius. We need to find out alpha, the temperature coefficient of resistivity. So we know alpha is equal to R2 minus R1 divided by R1 into T2 minus T1. Now by taking the values, 2.7 minus 2.1 divided by 2.1 into 100 minus 27.5. So that is equal to 0.6 divided by 2.1 into 72.5. After simplification, we will get 0.00394 degrees Celsius inverse. This is the temperature coefficient of resistivity of the silver material. Coming to 3.6. A heating element using nichrome connected to 230 volt supply draws an initial current of 3.2 ampere which settles after few seconds to a steady value of 2.8 ampere. If you observe here, the current is decreased from 3.2 ampere to 2.8 ampere. What is the steady temperature of the heating element if the room temperature is 27.0 degrees Celsius? Temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.70 into 10 power minus 4 degrees Celsius inverse. Here, the given data is V is equal to 230 volt and initial current I1 is equal to 3.2 ampere at temperature 27 degrees Celsius. And finally the current became 2.8 ampere. The reason for the decreasing in current is the initial temperature is 27.0 degrees Celsius only. As current is passing through the nichrome wire or any material, slowly the temperature increases. As temperature increases, the resistance increases. As the resistance increases, the value of current decreases. That's why the temperature increases and reaches the steady state. The current is fallen to 2.8 ampere from 3.2 ampere. And the value of alpha is equal to 1.70 into 10 power minus 4 degrees Celsius inverse. Now, the resistance at room temperature. We will find out the resistance based on V and I1 only. Resistance at room temperature. The room temperature here is nothing but 27.0 degrees Celsius. That is, we are taking here R1. Why means we have two currents, so we'll get two resistances. So R1 is equal to V by I1. That is 230 volt divided by 3.2. So that is equal to 71.875 ohm you will get after simplification. Now, the resistance of the same wire at steady temperature. Steady temperature means that temperature will be remains constant. R2 is equal to V applied is same, V divided by, but current is reduced, that is I2. 230 divided by 2.8, that is equal to 82.143 ohm. So we can observe here R2 is more than R1. Now we need to find out the steady temperature. We'll use the formula alpha is equal to R2 minus R1 divided by R1 into change in temperature, that is T2 minus T1. We can take T1 is nothing but room temperature, T2 is nothing but study temperature. From this formula, we can write T2 minus T1 is equal to R2 minus R1 divided by R1 alpha. That is equal to 82.143 minus 71.875 divided by 71.875 into 1.70 into 10 power minus 4. So that is equal to 10.268. In denominator 10 power minus 4 will come to numerator, that is 10 power 4 divided by 71.875 into 1.7. After simplification, we will get 840.35 degrees Celsius. That is T2 minus T1 value. From this, T2 is equal to 840.35 plus T1. That is equal to 840.35 plus 27. We will have 867.35 degrees Celsius. That is T2. That is also nothing but study temperature which is asked. Thank you.